In our lesson, we are going to cover Venn diagram. Please ensure you subscribe, like, comment, and share. We shall start direct from the what is Venn diagram, and then from there we shall look at applications or applying the Venn diagram in various mathematical problems. So simply a Venn diagram is just a schematic representation of the elements of a set. It's just that you're representing the elements of a set using diagrams. And the diagrams of sets of Venn majorly include the circle and then the rectangle, which possibly represent the universal set. Then the universal set, then the circle represent the sets with the elements. Sets with the elements. That is simply what is a Venn diagram. And then in Venn diagram, things that have commonalities are overlapping, meaning that if you are having common elements, that they show that sharing of elements are available in both set A and set B. We say those are commonalities, and in the circle they will overlap each other. While things that are distinct, they just stand alone, meaning that the elements of the two sets, there is no any intersection where the two sets meet. That shows now that the two elements will be distinctly described separately using the Venn diagram. This is the first sample of a Venn diagram. You have to draw that one. Then this is the universal set. Then you'll have you can draw a set, let's say set A, and then the set A will be containing the elements inside here. That's why it's just a representation of circles that shows a set and the elements in that set. Then you write the elements of that set, let's say 1, 2, 3. So set A has the elements that the elements as 1, 2, and 3. Now let's now apply the Venn diagram in a set operation so that you can see how they appear. Let's start with the union of a set. Let's start with the union of a set. A union of a set. This shows that in a union of a set, we are looking at all elements in set A, set B, or even set D that are common in both in all the sets. Either there are two or in all the sets. Let's see. Let's say set A has the members 1, 2, 3. Then set B has the members as 2, 4, 5. Then set C has the member 4, 6, 7. Those are the members of specific sets. Then let's look at a union between these sets, and then we shall see the application. So here, the union of A and B. A union B. We are looking for which elements are common between A and B. So you'll see that elements which are common between A and B, we are finding it is 2. 2 is the common between A and B. So when you're drawing your Venn diagram, you'll have to draw the Venn diagram. Start with the universal set. Then, because we are looking for union of A and B, there are 2 A and B, because there is a common element. That's why they are intersecting. Now the element that make them to intersect is 2. So and then this will be B and A. Then A will be remaining with 1 and 3. Then B will remaining with 4 and 5. So here now this is a union, and when we are talking about the union, is that we are picking all the elements across, meaning that now in our union means that all elements between A and B. So we shall just say it is 1, 2, 3, 4, 5. Those are the elements in that union. I've written here 2 because 2 is showing that essence of intersection which we are covering next, meaning that there is 2 in A and then again there is 2 in B. That's why the 2 are common. So that one now shows that there is an intersection, but we are looking for union of a set. So that shows the union of a set, and then this one shows the universal set. Then Let's look at the three. Let's I think it's not clear, so let's try to make it more clear. And then try to pick like this one, and try to pick like this one. Then this one is A, B, C. We're just looking at all elements that are present in A, B, and C. And we know A has elements 1, 2, 3. So the elements of A. Then B has the elements 2, 4, 5. Then C has the elements 4, 6, 7. So we shall be looking at all the elements across. That is why we now want to take all the elements. And here we shall just take that A union B union C, all the elements in A, B, and C. So we find that is 1, 2, 3. Then in B there is 2, so we don't write it is repetitive. So say we write 5. If we write 4, 5. Then we don't write 4 because it's repetitive. Then we write 6, 7. So these are the elements in that union. All the elements that are in that union without writing the repetition. Then these are universal set. The next part we are looking at set intersection. Here we are talking of set intersection. Let's show it with the help of Venn diagram. Set intersection. Then we just pick. Then we find that that is it, A and B. So this part we call it intersection. This is a part whereby these are the common elements between A and B. For example, where A we had 1, 2, 3, and then B our elements were 2, 4, 5. So here we see the 2 are common, and these are now they form intersection. So the 2 will be written here because that's the common, that's the intersection. Then the next part we shall look at again the complement. Let's look of complement. This was 2, then look 3. Complement, because the first one was union. Then complement of a set means that elements that are not in that set. That's why if you say A, then if you say this is A, then A complement will be here. So these are now the A complement, this part. Elements that are not in A but they are in universal set. That's why I present A complement of a set. Then union, complement of union of a set. So we are saying that complement. So this is our set. Then we draw that way. Then let's say set A and set B. Then the union of this set is all from A, B, all elements across. Then what is their complement? Their complement is this other part that is contained in the universal set. That's why I present this one as A union B. These are the complements. Then again we have another complements of let's talk of complements of intersection. Complement of intersection, and you'll find that complement of intersection is presented as follows. Complement of intersection. Yeah, complement of intersection. This is now the intersection. This is the intersection part. This is now the intersection part. Now the complement of intersection will be any other element that is not in the intersection point. All these other elements. These are now the complements of intersection of A and B. Yeah, then this one is A and this one is B. So this is how we have shown the complement of intersection. It will be A intersection B complement. So I'll find that this is how you draw it. So let me use another color so that this is the part we are talking of. This is the part we are talking of. And in this one, and in complement of union, this is now the union. This is the union, and then this other part is now the complement outside. So from there, let's do the last part, which we are tackling the set difference, representing the set difference with the Venn diagram. Set difference, and then set difference. Let's say A minus B. These are the two sets. Show the set, meaning that all elements that are in A but not in B. So just draw your Venn diagram as this way. Then you take there. This is A, and this one is B. So A, B elements that are in A, but they are not in intersection, meaning that they are not in B. So you put it this way. Yeah. This is a set difference. This shows now the elements that are in A, but they are not in B. Elements that are in A, but not in B. So this type of difference, we call it just symbol difference. Called symbol difference. So let's again look at the part that we call it symmetric difference, whereby symmetric difference is symmetric difference. We present A, B, or it can be represented as A, B. That's our symmetric difference. Representing a symmetric difference is that in symmetric difference, in symmetric difference, we are saying that these are elements that are in B or A, or in A or in B, but not in both. Not in both sets. They're either in A or in B. That's why. So these are now the elements in A, and these are the elements in B. We call it symmetric difference.